All right, let's talk about that feeling. You know the one? That jolt of frustration when your code just stops and your screen fills up with that infamous wall of red text? If that sounds familiar, you're in exactly the right place. Today, we're going to completely change how you think about errors in Python. We're going to turn them from these annoying roadblocks into some of your most powerful tools.
We've all been there, right? You write some code, you're feeling good about it, you hit run, and bam! That sinking feeling in your gut that says, great, I broke it. It's pretty much a rite of passage for every single person who learns to code.
But here's a thought. What if I told you that red text isn't actually a sign of failure? And that brings us to the real heart of what we're talking about today. In the world of Python, are these errors our enemies, or are they maybe our best, most honest teachers, trying to show us the way?
Okay, let's dive in. First things first, what we usually just call an error is technically known as an exception in Python. And it's not a crash in the way you might think. It's actually a specific event that interrupts the normal step-by-step flow of your program. When something weird happens, Python doesn't just break, it intentionally stops and raises an exception. It's a feature, not a bug.
So what kind of weird stuff are we talking about? Well, usually it's things that are just logically impossible. Like, trying to divide a number by 0. You can't do it in math, and you can't do it in Python. Or maybe you have a list with, say, 5 items, and you ask for the 10th one. It just doesn't exist. Or you try to open a file that isn't there. In all these cases, Python basically throws up its hands and says, whoa, hold on, this doesn't make any sense.
This gets right to the heart of Python's whole philosophy. It's from something called the Zen of Python, which are the guiding principles of the language. See, Python is designed to be loud and clear when there's a problem. The idea is that an error that goes by silently is way more dangerous than one that stops everything and announces itself. Python wants you to know the second something's wrong.
Now, it's really important to note there are 2 different kinds of errors. On one side, you've got syntax errors. This is basically bad grammar. You type something wrong and Python doesn't even know how to begin running the code. On the other side are exceptions, and that's our focus. Here, your code's grammar is perfect. It starts running, but then, in the middle of doing its thing, something unexpected happens.
And here's the kicker. If you don't do anything about an exception, it has one job and one job only: to stop your program dead in its tracks. A total crash. Now, for a tiny script you're just playing with, that's an annoyance. But for a real application that people are actually using, that's a complete disaster.
So how do we stop the crash? Well, Python gives us this amazing safety net, the try and except block. And the concept is beautifully simple. You put the code that you think might cause a problem inside the try block. Then you tell Python what your backup plan is in the except block. You're basically saying, hey, give this a shot, but if it doesn't work out, don't freak out. Just do this instead. And this is where the real magic happens. Imagine your program asks for someone's age, and they type in, hello. Without this safety net, your program just dies. But with it, you can catch that error and respond with a friendly message, like, whoops, please enter a valid number. Just like that, you've turned a hard crash into a helpful conversation.
Okay, so catching any old error that comes along is a great start, but it's a little like using a giant fishing net to catch one specific goldfish. I mean, it works, but it's not very targeted. So that leads us to a new question. Can we get more precise? Can we aim for just the specific errors we're expecting? Oh, you bet we can. Python has a whole toolkit of specific exception types, and this is where your code starts to feel really robust. If you're worried about a user typing text instead of a number, you can specifically catch a value error. If you're doing math, you can prepare for a zero division error. Working with files, you can anticipate a file not found error. By being specific, your code becomes way more predictable and a whole lot easier to debug.
Now, this try-except structure has one more trick up its sleeve, the finally block. Think of finally as a promise. No matter what happens, whether the try block succeeds or an except block runs, the code inside finally is guaranteed to execute. This is an absolute lifesaver for cleanup tasks, like making sure you always close a file you've opened.
And here's where you really get to take control. You don't have to just sit around and wait for Python to find a problem. You can actually create your own exceptions using the raise keyword. So if you write a function that should only ever get positive numbers and someone gives it a -1, you can raise your own error. It's a super powerful way to enforce the rules of your own code.
So, if we zoom out for a second, what's the big picture here?
It's a huge shift in mindset. Good error handling isn't about ignoring problems or pretending they won't happen. It's the complete opposite. It's about looking potential problems right in the eye and making a plan. And that, right there, is a hallmark of professional development.
And the payoff for thinking this way is massive. Your software becomes way more reliable since it doesn't just fall over at the first sign of trouble. You prevent those jarring, unexpected crashes, which means a much, much better experience for your users. And for you, as the developer, it makes finding and fixing bugs an absolute breeze. All of this really comes down to one core idea: defensive thinking. It's a mindset where you stop assuming everything will go perfectly. Because, let's be honest, it never does. You start asking, what if the user messes up? What if that file is missing? You prepare for things to go wrong, and making that mental shift is really what separates a beginner from a professional engineer.
So the next time you see that wall of red text, just take a breath. Don't think, I broke something. Instead think, okay, Python is trying to talk to me. It's giving you a signal, an invitation, saying, hey, something unexpected can happen here. Let's work together and figure out a smart way to handle it. And learning to listen to that invitation, that's the key to writing truly great code.